Alright, welcome back guys. We're going to look at 5.4. We're going to talk about something called the difference quotient. And we're going to calculate it, or at least simplify it, derive it, okay, for different functions. So what exactly is it? Well, I've got a picture here. It's basically the slope, okay, between any two arbitrary points on a function. So I did this in Desmos. I've got this parabola right here. So let's say that's my function, okay. And let's say I pick two arbitrary points. We'll say this point right here, and then this point over here. Let me zoom in a little bit more. Okay. So the difference quotient regarding these 2 points would just be the slope of this line. Okay, it's the slope of the line that goes through 2 arbitrary points on your function. Now, what if I didn't want to use this second point? Okay, and I wanted to use, I don't know, this point here. Okay, well then I'd have another line, right? I'd have a line. Let's see if I can draw this. Maybe should have done this in Desmos. That's not too good. Yeah, something like this. Okay, this will be my second point now. And so you'll notice the line that goes through these 2 points now has a different slope, doesn't it? It's not as steep as the line that went through the origin and this point up here. So that's what you're calculating when you calculate the difference quotient. And this is kind of what it looks like. It comes from the slope formula, if you remember. And we could even, let's see, I'm going to erase part of this. Let's call this point down here at the origin, we'll call it, let's say it has coordinates x1, y1. Okay. And then let's say that this point up here has coordinates x2, well, x2 comma y2. Or x2 comma y2. I'll go ahead and put the commas in there. Okay. Well, the way you would find the slope of the line that goes through these 2 points, or this line here in blue, is, if you remember, the slope is rise over run. Or in other words, the vertical change between these 2 points over the horizontal change. Okay. We can kind of look at this and say, well, to go from this point to this point, we're rising 4. Okay. And we're running 2. Okay, so the slope is essentially 4 over 2, or in other words, 2. So the slope of this line right here that goes through those 2 points is 2. Now, using the slope formula, okay, it is, to find that vertical difference, it's the difference in the 2 y coordinates, okay, divided by the difference in the 2 x coordinates. And if I were to do this, the y coordinate of this point is 4. The y coordinate of this point is 0. So 4 minus 0 divided by the x coordinate of this point is 2. And the x coordinate of this point is 0. So 2 minus 0. And again, we get 4 over 2 or 2. Okay. Now we go, I actually miscopied something here. The subscript should have been a 1. Now we make a more general case. Okay. So we say, okay, well, let's fix this first point, and then let's let our second point be any point just somewhere to the right. We can choose, any point somewhere to the right. Well, of course, depending on what point that is, the line that goes through those 2 points is going to have a different slope, isn't it? It's going to be steeper or not as steep, depending on what that second point is. Well, the difference between the x coordinates of those 2 points we refer to as h. Okay, So we'll say that the distance from this point, the horizontal change or difference between the x-coordinate of this point and this point we call h. Okay, so that's what you have right here. Because that's what you find when you use the slope formula. The difference between the two x-coordinates, we're just going to arbitrarily call it h. And then furthermore, the difference in those y-coordinates would be the function values. Okay, so if this is my first point, then the function value will be f of x, right? And then the y-coordinate of my second point will just be f of x with an extra h added to it. Okay, so f of x plus h. So it'll be the difference between those two things. Now in this example that I used here, h was 2. The horizontal difference between these 2 points is 2. Okay, and then the x coordinate of this first point was 0, so you'd be finding f of 0. That would give you your y1, and then 0 plus 2 would be 2, f of 2. That would give you your y2, okay, or 4 in other words. And so that's how we derive this difference quotient right here. Let me zoom out for a second. Okay, this is it right here. H just represents the arbitrary difference between the two x-coordinates. Okay, difference between the two x-coordinates. And then this piece right here, f of x plus h minus f of x, that just represents the difference in the two y-coordinates. But what this allows us to do, guys, is find the rate of change or the slope of a line that goes through, say, the origin and then any other point. Okay, whatever that point is will fix the value of h. Okay, so as I put here in the notes, it allows us to calculate the slope, which represents the average rate of change, by the way, between two arbitrary points on a function, as long as you know the first point. As long as you know the coordinates of that first point, then h will just be how far away horizontally that second point is going to be. And then f of x plus h will be how far away vertically that second point is. Okay, so this is a general formula. And if you ever take calculus, you're going to be working with this a lot. Because in calculus, you're not really concerned about what's the rate of change between 2 points. Rather, what's the rate of change at just 1 point on the function, the instantaneous rate of change. That's how it's referred to in calculus. And this line right here that goes through these 2 points, guys, this is called a secant line. So when you're calculating the difference quotient, you're really just calculating the slope of that secant line, okay, for any 2 arbitrary points on that function. So the slope will depend on where those 2 points are. It'll depend on what the first point is, where you put the first point, and it'll depend on where you put the second point. Okay, how far away horizontally and vertically is that second point from the first point. So that's geometrically kind of what's going on here. Okay. Now, the bulk of this section is just strictly using this difference quotient, or this formula right here, to find the difference quotient for different functions. Okay. So we're going to start, well, one right here has been worked out for you. We can walk through it real quick, and then we'll do example 1. And I think we may save examples 2 and 3 for a part 2 video. So let's look at this example. So let's say that this is our function. F of x is equal to 3x minus 2. Well, that's a linear function. It's not a quadratic, so it's just a straight line. Okay. So this is my difference quotient right here. This is the formula. So to find f of x plus h, you plug x plus h into your function, and that's what they've done right here, okay, in this first part. Okay, that's f of x plus h minus f of x. Well, f of x is just this guy right here, 3x minus 2, so it's right here, minus f of x, and then this is all over h, okay? And then what happens is you basically simplify this. So when you're finding the difference quotient, you're going to be doing a lot of simplification. You first distribute the 3, so you get 3x plus 3h, and you have minus 2. And then you distribute this negative, and it's imperative that you keep that second function in parentheses, because that'll give you a negative 3x plus a 2. Okay, and then you keep working here in the numerator. You'll end up typically canceling a lot of terms in this step. 3x with this negative 3x would disappear. This negative 2 with this plus 2 will disappear, and all we'll end up with is 3h on top over h, and then those h's divide out, and we're left with just 3. Okay, so what does 3 mean? Well, let's graph this function. Let's do it in Desmos. Okay, I'll clear those other two that I did real quick. It was 3x minus 2, I believe. Yeah, 3x minus 2. So this is what the function looks like. And what the difference quotient tells us is that if I choose any two arbitrary points on this function, the line between those 2 points will have a slope of 3. That's what this is telling me right here. And it'll always be 3. It doesn't matter which 2 points I pick. And the reason is because of the nature of the function. This is a linear function. It never changes. Its rate of change is always 3. It's always going to have a slope of 3. It doesn't matter which 2 points I pick. Okay? Now, if we're looking at a different function like x squared, a quadratic function, then it's not constant. Depending on which 2 points I pick, the slope of that secant line will vary, and it'll depend on the value of x of that first coordinate and the value of h. In other words, how far apart are those 2 points horizontally. Okay? So, anyway. So the difference quotient for a linear function is just going to be the slope. It's just going to be 3, so you can just look at it and tell. In fact, that's what we're going to see right here with example 1. Example 1, it says for this function, which is linear, by the way, as well, 5x minus 4, construct and simplify the difference quotient. Well, I can look at it and tell it's going to have a slope of 5, so the difference quotient is going to be 5. Okay, but let's actually work it out. Let's use the formula, because this is important that you're able to do this. So it's going to be f of x plus h minus f of x. Okay, so remember, this is like our y1, this is like our y2, and then our x2 minus x1 we're just calling h. That's just the difference, the horizontal difference, or the difference between the two x coordinates. Okay. Alright, well, f of x plus h means I take x plus h and I plug it in for x. So if I do that, I'll have 5 times x plus h minus 4. Okay. Then I bring down this minus sign because that's part of my formula. And then I plug in x plus h. Well, x plus h is just the function itself. But I need to keep it in parentheses. It's 5x minus 4. Okay. And then I put all of this over h. And then I proceed to simplify. So when I simplify, I'm going to distribute first. I'm going to distribute this 5. So 5 times x is 5x. 5 times h is 5h. Carry over my minus 4, and then I need to distribute my negative right here. And that'll just change the signs of those two terms. It'll become a negative 5x. That'll become a positive 4. And now again, this is still all over h. typically, guys, what I will do is I'll just work out the numerator first, get it simplified, and then at the end I'll put it over h and see if there's anything else I can do. But what you'll notice here is we're going to have some terms eliminate, and this is very common. If nothing is canceling up here, then you've probably made a mistake. 5x minus 5x is 0. Negative 4 plus 4 is 0. Okay, and so we're only left with 5h in the numerator. So this will equal 5h over h, and then those h's divide out. Okay, and so we end up getting 5, like we said we would. Okay, so the difference quotient for a linear function is just the slope of that function, because it doesn't matter what 2 points you use. The line will be on top of the line that's already there, and it has a slope of 5. So the slope of your secant line will always be 5. And the reason is because that linear function never changes. It's always, the steepness of it is always the same. But that's not always the case with these other functions. This next one, for example, this is quadratic. So its steepness is constantly changing, right? Okay. So the slope of a secant line that goes through 2 arbitrary points will constantly be changing as well, depending on which 2 points that we use. You know, I think I'm going to, why don't I just go ahead and do this one, and yeah, let's go ahead and do this one, okay? So we'll do the same thing, f of x plus h minus f of x, and this is all divided by h. So I'm going to go ahead and set up a function. So I'm going to take x plus h and plug in from the x's in my function. So I'll have 2 times x plus h squared minus x plus h, and then I'll have a minus 3. Drop down the minus that's in my difference quotient and then plug in f of x. Well, it's this quadratic function. It's 2x squared minus x minus 3. Okay, and then again, technically this is all over h. Okay, but we've got a lot of simplifying to do here. The first thing we need to do is address this exponent, x plus h squared. Okay, this is not x squared plus h squared, because you have to remember, when you square a binomial, you're multiplying it by itself, and you have to multiply these two using the FOIL method or the distributive property, depending on how you look at it. So x times x is x squared, x times h is xh, h times x is still xh. The order in which you write those two doesn't matter. I like to keep the order consistent because it helps me see that these are going to be like terms that I can combine here in a second. And then finally, h times h is h squared. Okay, and then so those two terms in the middle, xh plus xh is 2xh. And then I'll rewrite everything else. Okay, so that's actually what goes in for this piece. Now I still have to multiply everything by 2. Okay, so I still have 2 times what I just came up with, that trinomial. 2xh plus h squared. I still have, I'm just going to recopy everything. Okay, I'm trying to do this step by step for you. Okay, I'm going to ignore the h on the bottom here for a minute. Now my next step is some distribution. I'm going to distribute this 2 here, distribute this negative, and distribute this negative. So if I do that, I'll have 2x squared plus 4xh plus 2 h squared, and that negative will just change those signs. Oops. Okay, minus h, minus 3, then distribute this negative, so negative 2x. That'll become a positive x, and then that will become a positive 3. Alright, finally. Okay, so a lot of just mechanics here. Now, let's look and see what we can cancel. Well, I've got a positive 2x squared and I've got a negative 2x squared, so those are gone. Let's see what else. I've got a negative x and a positive x. I've got a negative 3 and a positive 3. And I don't really see anything else. Okay, so I'm left with three terms, this 4xh plus 2h squared minus h. And when I rewrite this, I'm going to kind of change up the order. I want to put the h squared term first, and then the 4xh, and then the minus h. Okay. Now I will go ahead and put this over h now. Now there is one last thing that we can do to simplify. All three terms in the numerator have at least one h, and so we can divide this h that's down here in the denominator into all three of those terms. Typically what's done is you factor an h out of all three of these terms, okay, and then divide it out with this h on the bottom, and that's the way I'm going to do it. So if I take the h that all three of these terms have, I take it out, it would be my greatest common factor. I would just be left with 2h plus 4x minus 1. You've got to be careful here, because when you're factoring the h out, you're doing the opposite of distributing the h. So I need to make sure a 1 stays right here, such that if I were to distribute this h, I would get back my negative h. Okay? And then I'll write this over h. And now we divide those h's out. Okay? Now you can divide them out. You can only do this if h is common to all of your terms. Okay? You factor it out and then divide it out with the h in the denominator. And so what do we end up with as our difference quotient? Well, something that looks like nothing we've seen so far. 2h plus 4x minus 1. So what does this mean? Well, this means that the slope of the secant line between two arbitrary points on my parabola will depend on the x value of that first point, and it'll depend on h. Well, h is just how far apart the 2 points are, the difference in those x coordinates. Okay, and so this is pretty fascinating, because you can take your parabola right here, you can pick any 2 points anywhere, take the x coordinate of that first coordinate, the x coordinate of that first point, and the difference in the x coordinates. Okay, so wherever that second point is, how much larger it is, okay, that's your h. Plug those values for x and h in here, and that will give you the slope of that line, of the line that goes through those 2 points. So this is this ends up becoming a function not just of x, but also of h. Alright, you know what, we've got enough time to go ahead and do example 3, I think. So let's go ahead and do it. Now example 3 is a cubic function. We can graph it if you want. 7x cubed, 7x, let's raise this to the 3rd power, and this is what we get. So again, you know, depending on which 2 points I choose, this function, its steepness is always changing, isn't it? So the difference quotient is not just going to be a constant. Alright, so let's try this one. F of x plus h minus f of x all over h. Okay. Well, f of x plus h, I just plug x plus h in for x. It'll be cubed minus, and then I'll plug in f of x. Well, f of x only has one term. So when your function only has one term, you don't have to keep it in parentheses. Okay. And then this will be over h. Now you may be thinking, oh, well, this one's going to be easy to simplify. Well, you actually have to cube this binomial right here. And so that involves, well, let me zoom out so I have a little bit more room. That involves multiplying x plus h times itself 3 times. Okay. So similar to what we did previously, but then one more time. So I'm going to grab what I had from above and just copy that. That'll save me a little bit of work. Okay, and I'm going to keep this in parentheses because I still need to multiply it by this last factor of x plus h. Okay, so this is where kind of the work comes in, all this multiplication. So to do this, you're still using the distributive property. You're going to multiply every term in the first trinomial to both terms in the second binomial. Okay, so x squared times x to the first will be x to the third. X squared times h will just be x squared h. And then you're going to distribute your 2xh. 2xh times x will be 2x squared h. You got to be careful here. Pay attention to what you're doing. 2xh times h will be 2xh squared. And then finally we distribute our h squared. H squared times x, I'm going to write this as x h squared because the order doesn't matter. And it allows me to see that this term will actually combine with this one. And then finally, h squared times h to the first is going to give me h to the third. Okay, so I end up with 6 terms. Let's see if any of them can be combined. Well, 1x squared h plus 2x squared h will give me 3x squared h. Nothing's going to combine with that x cubed. And then over here, these two, 2xh squared plus 1xh squared will give me 3xh squared. And then finally I'll have that h cubed at the end. Okay. So I ended up with 4 terms. So now I'm going to copy all those. I still need to keep that in parentheses because I still have to distribute this 7 right here. So x cubed plus 3x squared h plus 3xh squared plus h cubed, and then copy the rest of it, minus 7x cubed. Now I'm going to worry about the h on bottom here in a minute, because now what I'm going to do is distribute my 7. And if I do that, I'll get 7x cubed plus 21 x squared h plus 21 x h squared plus 7 h cubed minus 7x cubed. Okay. Now I'm going to keep working because I think I may have at least a couple terms that will cancel. And in fact, the 7x cubed with the negative 7x cubed will cancel. And guys, that's actually all that will cancel. So I'm going to have these 3 terms left. 21x squared h plus 21xh squared plus 7h cubed. Now, this one's similar to the last one. These 3 terms do have something in common, but it's just an h. Okay, so if I take the h, well actually it's a 7 as well. They all have a 7 in common. But I'm not going to take out the 7, and the reason is because all I have in the denominator is an h. I don't have a 7 down here as well. So if I took the 7 out, I wouldn't be able to cancel it. But I will be able to divide out the h. So I'm going to take an h out. That'll leave me with 21x squared plus 21xh plus 7h squared. Okay, and then when I put this over h, of course, those h's will divide out. And this is finally going to leave me with just 21x squared plus 21xh plus 7h squared. So this one's similar to the last one. This one depends on x and h again. Okay? And guys, the more complex the function is, the more complex the difference quotient will be. Okay, so anyway, I hope that you understand this conceptually. I tried to explain kind of what exactly it is that you're finding. This is just a formula for the slope of a secant line between any two arbitrary points on that function. And once you know what those 2 points are, then you'll have a value for x and you'll have a value for h. Okay, and it'll give you the slope of that line that goes through those 2 points. But that slope will change depending on what those 2 points are. Because if you look back here at this function, it's the steepness or its slope is always changing, isn't it? Alright, so anyway, we ended up at about just a hair over a half hour. I hope this made sense, guys. If nothing else, it's just a lot of, I guess, work in elementary algebra. Just a lot of multiplying binomials, using the distributive property, factoring an h out, canceling an h to simplify. Just a lot of simplification, basically. Alright, well this is the last section that we cover before our Module 2 exam. Okay.